This video is about a concentration unit called molarity. Essentially, we're talking about how much solid is dissolved in a certain amount of solvent. Okay? Remember, it's the solute that gets dissolved in the solvent to make a solution. So the solute is the solid, the solvent is the liquid, usually. Could be a solid and a solid, or a liquid and a liquid, but for the most part, solid, liquid. And for the most part, we're talking an aqueous solution, a solution where the solvent is water. Now, there are a lot of concentration units. The one we are talking about, we are emphasizing, is this thing called molarity. The definition of molarity is moles of solute over liters of solution. Notice solution, not the solvent, it's the whole solution. Technically, that counts for the volume that the solute's taking up also. And the symbol, we've run into this before, the symbol is a capital M. That means molarity. Moles of solute, liters of solution. There are several ways we can use molarity. One of the most important is to use it in stoichiometry. Just like, remember we did this in the lab, the precipitation lab. If somebody says to you they mixed 30 milliliters of a 6 molar solution, then you would say, oh, that means 0.030 liters, because remember my definition involved liters, not milliliters, and 30 milliliters is 0.030 liters. So 0.030 liters times 6 molar, or 6 moles per liter, is going to give me moles. 6 times 3 is 18. So that's 0.18 moles. And then you're free to use this in stoichiometry. Remember, of course, if you're using it in stoichiometry, then of course you would start with now 0.18 moles of whatever it was and go straight into the mole to mole ratio and whatever balanced chemical equation you had. Don't go from moles to grams. That's never ever your first step in stoichiometry. Don't go from moles to grams. Your whole point is usually to go to grams to moles. You'd already be at moles and you could go straight into your mole to mole ratio. That is most often how you would use molarity. Now, to actually make a solution of a particular molarity, you usually would use what's called a volumetric flask. This is an example of a volumetric flask. You'll notice there's a line. That tells you that's the level of liquid you're going to fill up. This one happens to be a 500 milliliter volumetric flask. So the only thing you can measure in this volumetric flask is 500 milliliters. That's what it's made for. It is not made to measure anything else. You'll get terrible significant figures if you try to measure anything other than what it's supposed to be. And they make them in different sizes. There's 50s and 25s and 500s and hundreds and 250s and liters. So it's very important to pick the volumetric flask that you want for any particular application. Now, to make a solution of a specific molarity, first you would need to know exactly what you had. So let's say you're making, for the sake of ease, you're making a 0.250 molar solution of sodium chloride, and you're going to make 500 milliliters of that. Okay, so your first step Okay, so again, figure out moles. So 0.500 liters times 0.250 molarity equals, which would be 0.125 moles of NaCl. But obviously I can't go and measure 0.125 moles of NaCl, so this time I do have to go to grams. So 0.125 moles of NaCl. For every 1 mole of NaCl, sodium's 23, chlorine is 35.5, so that's 58.5 grams. That's molar mass, right? And I do my math here, and I say 0.125 times 58.5 is 7.31 grams. So, I walk over to the balance, and I mass 7.31 grams of NaCl in some sort of weigh boat or beaker or something. Now, the easiest thing to do, remember we're going for 500 mils here. So the easiest thing to do, so step 1 was mass the correct number of grams of solute. Your next step, because it's usually much easier to transfer liquid than it is to transfer solid, I would actually mass that in a small beaker and then add some of the solvent to the solid and dissolve it. Then, very carefully, using a funnel probably, transfer that liquid to the volumetric flask. Now you have to be careful here because you don't want to dissolve the solid in too much liquid. Remember what my volumetric flask looked like. It looks like this. What you want is to have the liquid no more than about halfway up this bulb part. Okay? No more than about halfway up this bulb. Then you can put a stopper in it, you mix it up, you make sure it's all mixed. Then you very slowly add the water until you get very close to the top. Now, voice of experience here, once you get to this thin neck, water level shoots up really fast. You have to be very careful. So what you want to do is when you get very close to the top, you stop pouring the water in and use a dropper. And go very slowly up to that line with drops. Remembering your meniscus. That is, remembering that water really looks like that. And you want the bottom of the meniscus to be in line with that line. Okay? So very slowly. Once you get to the top, very slowly add water until you get to the line. And then mix again. Put your stopper in and mix it up. Then you're ready to go. You can use it in whatever it is you need to use it in. You'll notice, by the way, nowhere did I say, now add 500 milliliters of water. Again, it's not milliliters of solvent. It's milliliters of solution. The solute takes up some room. So you're adding until the water reaches 500. You're not adding 500 mils. Okay? That's a distinction. It's a picayune distinction, but it's an important distinction. Now, remember that if you pour some out, you now have 500 milliliters of a 0.250 molar NaCl solution. Let's say you're going to add this to a solution of silver nitrate. Okay? So you've got this, and you're going to add some to some silver nitrate. You're going to say NaCl plus AgNO3 gives you NaNO3 plus AgCl. And AgCl is a solid, all these others are aqueous, you're going to get a precipitate, just like the lab we did. Let's say you say to yourself, I want, to end up with 0.5 grams of AgCl. How many milliliters of NaCl should I start with? Okay? So now I'm going to say 0.5 grams AgCl. I need the molar mass of AgCl. Silver is 108. Chlorine is 35.5. So 108 plus 35.5 is 143.5 grams in a mole. That's all a 1-to-1 ratio. So for every 1 mole of AgCl, there's 1 mole of NaCl. We can actually stop right there. 0.5 divided by 143.5 times 1 divided by 1 is 0.00348 moles of NaCl. Okay, so out of this 500 mils of 0.250 molar NaCl, I want to take out an equivalent of 0.00348 moles of NaCl. How do I figure out what volume that is? Because remember, what I can't do is turn this moles into grams and go over to a balance and mass it, because I don't have any solid NaCl. The only NaCl I have access to has already been dissolved in this solution. Remember our definition. Molarity equals moles over liters. That means liters times molarity equals moles, and liters equals moles over molarity. So I want to know liters. I want to know how much of that 500 mils contains that much moles, 0.00348. So what I can say is 0.00348 divided by the molarity, which is 0.250, is 0.0139. Don't forget your figs here. There's only 3 and 3. 0.0139 liters, which is 13.9 milliliters. So I know that I should add 13.9 milliliters, or at least 13.9 milliliters, depending on, what's the limiting reagent here. But assuming this is a limiting reagent, I need to add 13.9 milliliters of my solution with, however, my excess AgNO3 to get 0.5 grams of AgCl. So that's how I do stoichiometry mixed with molarity. This whole idea of figuring out what volume gives us what moles actually also ties into something called dilution. Let's say I still have my 0.250 molar NaCl and 500 mils of it, and I want to make, change my pen color here, I want to make mils of a 0.100 molar solution. But the only thing I've got to work with is this solution. So once again, I cannot go over to a balance and mass out some grams. I don't have solid stuff. I have liquid. I have a solution. So my first thought is how many moles of NaCl, just the same as I just did in that stoic problem, how many moles of NaCl is in this 500 mils of 0.1 molar solution that I want to make? So that's 0.100 molar times 0.500 liters, which is 0.050 moles of NaCl. So now I have to say to myself, what volume of this solution, my original solution, is going to give me that many moles? So once again, it's going to be molarity is moles per liter, and liters is moles over molarity. So it would be 0.050 over my 0.250 molarity, which is 0.200 liters, or 200 milliliters. So procedurally, what I would do is pour 200 milliliters out of this 500 into a new volumetric, and then dilute up to 500 mils with water, and now I have diluted my solution. Okay? It's less concentrated. Picture, if you will, a pitcher of Kool-Aid. You pour a glass of Kool-Aid into a new pitcher and dilute, your Kool-Aid tastes more dilute. You have a much more dilute solution, because the only Kool-Aid in your new pitcher is the stuff you took out of the old pitcher. So the only NaCl in this blue solution is the stuff I took out of this black solution. Alright? Okay. That's really all there is to know about molarity. Those are the only kind of molarity problems I can give you. Molarity and stoic, dilution molarity, or how to make the particular solution in the first place.